In this final exam problem, we are given a regular language in the form of a non-deterministic finite state machine, and we want to construct another non-deterministic finite state machine that accepts exactly the same strings but backwards. So let's say we have this regular expression that accepts strings that begin with an A and end with a C, and in between have one or more occurrences of bx and by. An example string that regular expression matches looks like this: A, bx, bx, by, and c. So we do A, bx, by, and then c. So here I have a finite state machine representation of that regular expression. We start with an A, we require at least one bx or by, and then we can repeat the bx and by afterwards as many times as we want, and we finish with a c. Remember, the finite state machine we want to generate will have to accept strings like this, where we begin with a c, we then have yb, xb, xb, and then a. Our strategy for doing that is going to be basically reversing all of the edges in this finite state machine to go the other direction, and finishing it off by changing the start state with the accepting state. Okay, so the first thing I'm going to do is change the start state and the accepting state. So now we start at 6 and finish at 1. And now I'm going to change all of the arrows. And we're done. If you look closely, you'll see that this finite state machine matches exactly the same set as the original one, finite state machine, but backwards. So let's apply that same methodology to coding our solution. So I've started coding the solution, and the first thing I do is create a dictionary to contain the reversed edges, and I switch the start and accepting states. Now I'm going to go through each of the original edges, and right here on these 3 lines, I'm just extracting the data from the original edge and the original finite state machine to make it easier to manipulate later. So for this edge in the original finite state machine I'm looking at, I'm going to go through each of its destinations so that I'm going to create an edge that goes the other direction. And because the way we structure our data structure, I'm going to have to do it in kind of a continuing fashion. I can't just finish the edge. I have to look at every edge in the original one before I can be certain that I've finished the edge in the new finite state machine. So this line of code sees if we've already created the beginning of this edge, and that's going to overwrite the empty list we have before. And either way, we're going to set the new state of this edge in the new finite state machine to be the concatenation of the before list with the added state that we got from this iteration. And once we're done going through the original finite state machine, we just return the result.